Algebra, Chapter 2, Quadratic Equation, Module 1. In this module, we'll study the introduction to quadratic equations. Standard form of a quadratic equation. Let us understand what is the general form or the standard form of a quadratic equation. The equation involving only one variable and having 2 as a maximum index of that variable, such type of equation will be called as a quadratic equation. See, the general form is ax square plus bx plus c equal to 0. So if you can see in this equation, there is only one variable x and the maximum index of that variable x is 2. So whenever an equation having one variable only and the maximum index or the maximum power of that variable is 2, then we call such type of equation as a quadratic equation. And a, b and c are real numbers such that a is non-zero. So a should be a non-zero real number and b and c can be any real number. Let us see for examples, some examples which are quadratic equation, and we'll write it in the general form and try to identify the values of a, b and c in that quadratic equation. So if we see the first equation, x square minus 4. If we try to write this equation in the general form of quadratic equation, we have x square plus 0x minus 4 equal to 0. So since the term containing x is absent, so we just write it as 0x minus 4. Now if we try to find out a, b and c, so if you note, a is a coefficient of x square, and in this case the coefficient of x square is 1, so a will be 1. B is a coefficient of x, so in this case the coefficient of x is 0, so b will be 0. And c is the last constant term in the quadratic equation, so in this case the last constant term is minus 4, so c will be minus 4. Let us see another equation. So if you can see, the another equation is y squared equal to 2y minus 7. If we just try to rearrange this and try to write it in the general form, so we get y square. We'll take this plus 2y and minus 7 term on the other side of the equal to sign. So we get minus 2y plus 7 equal to 0. Now we'll try to identify the values of a, b and c. So a will be the coefficient of the square term. So coefficient of y square is 1. So you will have 1 here. B is a coefficient of y. So in this case, the coefficient of y is minus 2. And c is the last constant term. So in this, the last constant term is plus 7. Let us see one more. X square plus 2x equal to 0. This again, we'll try to write it in the general form. So if we write it in the general form, if you see the last constant term is absent, so we'll just write it as 0. So this becomes x square plus 2x plus 0 equal to 0. Now try to identify the values of a, b and c. Coefficient of x square is 1, so a is 1. Coefficient of x is 2, so b is 2, and the last constant term is 0. So we'll have c equal to 0. Now let us try to decide which of the following are quadratic equations. Let us see some examples. So the first one, 3x square minus 5x plus 3 equal to 0. So if you can see in this, the square term is present, x term is there, and there is a constant term. So if we try to write this in the general form, ax square, if we try to compare it with the general form, ax square plus bx equal to 0. So this is in the general form. So this is a quadratic equation. If you see the another one, 9y square plus 5 equal to 0. Again, if we try to write this in the general form, we'll have 9y square. The term with the variable y is absent. So we'll write here 0y plus 5 equal to 0. So we can see this is also a quadratic equation. If we see the third one, m cube minus 5m squared plus 4 equal to 0. Now we know by the definition of quadratic equation, it has to have one variable and the maximum power of that variable has to be 2. But in this case, although it has only one variable, but the maximum power of the variable is 3. So this is not a quadratic equation. If you see the last one, we have I plus 2, I minus 5. So this is I plus 2, I minus 5 equal to 0. Now, this is not in the general form of the quadratic equation. We'll just try to do bracket to bracket multiplication and we will write it in the general form and then identify whether it is a quadratic equation or not. So we'll do first bracket to bracket multiplication. So I into I minus 5 plus 2 into I minus 5 equal to 0. So if you multiply the I inside, this becomes I square minus 5i plus 2i minus 5 into 2, 10 equal to 0. So this will become I square minus 5 plus 2i will give you minus 3i minus 10 equal to 0. Now if you look at this equation, this is in the general form of the quadratic equation. There is only one variable I and the maximum power of that variable is 2. So this is a quadratic equation. Roots of a quadratic equation. Let us try to understand what is the meaning of root of a quadratic equation. If px is a polynomial and p of a is equal to 0, that means in the polynomial px, in place of x, if you substitute a and you get it equal to 0, then I will say that x minus a is a factor of the polynomial px. And in this case, a is a root or solution of the polynomial px equal to 0. Let us try to understand this with an example. Let x is equal to minus 6. That means we'll substitute x is equal to minus 6 in the polynomial x squared plus 5x minus 6. So in place of x, I'll substitute minus 6. So this is x squared. So it becomes minus 6 squared plus 5 into x. So 5 into minus 6 minus 6. So 6 minus 6 squared will be 36. Plus into minus will give you minus 5 into 6, 30 minus 6. So here you will get 36 minus 30 minus 6 will give you minus 36. So this will be 36 minus 36, which is 0. So you get your 0. So that means you can say that x is equal to minus 6 is a solution of the equation. Or you can also say that minus 6 is the root of the equation. Now let us substitute x is equal to 2 in the polynomial x squared plus 5x minus 6. So in the polynomial x squared plus 5x minus 6, in place of x, I'll substitute 2. So x squared will become 2 square plus 5 into x, so 5 into 2 minus 6. 2 square is 4, 5 into 2, 10 minus 6. So 4 plus 10 minus 6 will give you 8, which is not equal to 0. So in this case, in this polynomial, after substituting x as 2, I'm getting a number, a non-zero number. So in this case, I will say that x is equal to 2 is not a solution of the equation x squared plus 5x minus 6 equal to 0. Let us decide which of the following are quadratic equations or not. This is a practice set 2.1, the second sum. So deciding which of the following are quadratic equations. So first one, x squared plus 5x minus 2 equal to 0. So if you see, there is only one variable in this equation, that is a variable x, and the maximum index or maximum power of the variable x is 2. So I can say that this is a quadratic equation. Let us see the next one. The next sum, y square is equal to 5y minus 10. In this, if you notice, there is only one variable y, and the maximum index of this variable y is 2. So I can say it is a quadratic equation. Okay, if you look at this, y square plus 1 upon y equal to 2. Now we'll just try rearranging this. So we'll take the LCM. So after taking the LCM, you will get y cube plus 1 upon y is equal to 2. Now you just cross multiply, you take this y on the other side. So we'll have y cube plus 1 is equal to 2y. Now you just take this plus 2 on the other side, become minus 2y. We'll just do the rearranging. So we'll have y cube minus 2y plus 1 equal to 0. Now we'll try to identify this equation, whether it is a quadratic equation or not. So you see we have y cube minus 2y plus 1 equal to 0. So if you see, there is only one variable y, but the maximum index of the variable is 3. So this is not a quadratic equation. So we know for a quadratic equation, the maximum index has to be 2. Okay, if you see the fourth one, x plus 1 upon x is equal to minus 2. Again, we'll just try to take the LCM and do the rearranging. So if we take LCM, we'll have x square plus 1 upon x is equal to minus 2. Now you just take the x on the other side, do cross multiplication, we'll have x square plus 1 equal to minus 2x. We'll just rearrange, we'll take minus 2x on the other side. So I'll have x square minus will become plus, so plus 2x plus 1 equal to 0. Now I'll try identifying this equation. Now if you see this equation, x square plus 2x plus 1 equal to 0, it has only one variable x, and the maximum index or the maximum power of the variable x is 2. So I can say that this equation is a quadratic equation. It is a quadratic equation. Okay, fifth one. Let's see this whether this is a quadratic equation or not. We have m plus 2, m minus 5 equal to 0. So in this case, first what we'll do is we'll try to do the bracket to bracket multiplication. So you multiply m with m minus 5 plus 2 into m minus 5 equal to 0. In this case, multiply m inside, so m into m will give you m square minus 5m plus 2m minus 10 equal to 0. So just try to rearrange this, simplify it. So we have m square minus 5m plus 2m will give you minus 3m minus 10 equal to 0. So we have m square minus 5m minus 10 equal to 0. So we'll just try now identifying this equation. So if you see m square minus 3m minus 10 equal to 0, it has only one variable m, and the maximum index of this variable m is 2. So it is a quadratic equation. See the sixth one, it is m cube plus 3m square minus 2 is equal to 3m cube. If we try rearranging this, and still you will get the m cube term. So you see it has entire equation has only one variable m, and the maximum index of the variable m is 3. So even if you try to rearrange, the maximum index of this equation will be 3 itself. So I can say that it is not a quadratic equation. We'll move on to the next sum of practice set 2.1, the question 3. So we have to write the following equations in the form of ax squared plus bx plus c equal to 0, that is in the general form, and then we have to write the values of a, b and c for each equation. So the first one is 2y minus 10 minus y squared. So we'll just try to rearrange this, and changing the sign throughout, we get y square minus 2y plus 10 equal to 0. So on comparing the above equation with the general form, that is ay squared plus by plus c, we get the coefficient. So if you see, coefficient of y square is 1, so a is 1. Coefficient of y is minus 2, so b is minus 2. And the coefficient of c is 10. So the constant term in the equation is 10. So C is equal to 10. Let us do the second sum. X minus 1 the whole square is equal to 2x plus 1. So first we'll just try simplifying this. We'll expand x minus 1 the whole square. So we'll use the formula a minus b the whole square, which is a square minus 2ab plus b square. So we'll use this formula and we'll expand the term x minus 1 the whole square. So after expanding, I'll get x square minus 2x plus 1 is equal to 2x plus 3. Now if you take this term 2x plus 3 on the other side, we'll have, and we'll try rearranging it. So plus 2x if I take on the other side, it will become minus 2x, and plus 3 if I take on the other side, I'll have minus 3 equal to 0. Now minus 2x will give you minus 4x, and plus 1 minus 3 will give you minus 2 equal to 0. So I have the new equation, new quadratic equation, that is x squared minus 4x minus 2 equal to 0. Now if you compare this equation with the general form ax squared plus bx plus c equal to 0, we get coefficient of x squared is 1, coefficient of x is minus 4, and the constant term is minus 2. So c is equal to minus 2. Let us see the third sum. X squared plus 5x is equal to minus whole bracket of 3 minus x. So here first what we'll do is we'll open this bracket, we'll multiply the minus sign inside. So we get x squared plus 5x minus 3x, and this minus into minus will give you plus, so it becomes plus x. So we have x squared plus 5x is equal to minus 3 plus x. Now if we take the terms minus 3 plus x on the other side, this minus 3 will become plus 3, and this plus x will become minus x. So we have x squared plus 5x minus x plus 3 equal to 0. So we'll just try solving this, simplifying it. So 5x minus x will give you 4x, and this plus 3 as it is. Now if we compare this with the general form ax squared plus bx plus c equal to 0, we get coefficient of x squared is 1, so a 1, coefficient of x is 4, so b is equal to 4, and the last constant term is 3, so c is equal to 3. The fourth sum, 3m square is equal to 2m square minus 2. This also we'll just first try rearranging and simplifying it. So if we take the 2m minus 9 on the other side, so plus 2m square will give you minus 2m square, minus 9 will give you plus 9 equal to 0. So if you see, these are the square terms, so 3m square minus 2m square, so it will get subtracted, so 3 minus 2 is 1. So you have m square plus 9 equal to 0. So if I just try writing this in the general form, so the term with m is missing, so I'll write m square plus 0m plus 9 equal to 0. Now if we compare this with the general form of the quadratic equation, am square plus bm plus c, so the coefficient of m square is 1, so a is 1, coefficient of m is 0, so b is equal to 0, and the last constant term is 9, so c is equal to 9. Let us do the last sum, the fifth sum. So p is equal to 3 plus 6p is equal to minus 5. So first we'll start simplifying and rearranging this. So we'll multiply the p inside the bracket. So you multiply the p inside, I get 3p plus p into 6p will give me 6p square equal to minus 5. So we'll take this minus 5 on the other side and we'll just rearrange this. So I have 6p square plus 3p plus 5 equal to 0. Now if I compare the above equation with the general form, we get coefficient of p square is 6, so a is 6, coefficient of p is 3, so b is equal to 3, and the last constant term is 5, so c is equal to 5. The sixth sum, if you see, x square minus 9 equal to 13. So here also we'll just simplify and rearrange this. We'll take the 13 plus 13 on the other side. So it becomes minus 13. So you have x square minus 9 minus 13 equal to 0. So in minus 9 minus 13 will give you minus 22 equal to 0. So if you see, if we try writing this in the general form, we have x square plus 0x. So since the x term is missing, you'll write 0x minus 22 equal to 0. Now if we compare this with the general form, ax square plus bx plus c equal to 0, Coefficient of x square is 1, so a is equal to 1. Coefficient of x is 0, so b is equal to 0. And the last constant term is minus 22, so c is equal to minus 22. Question number 4 of your practice set 2.1. So we'll do the first part of it, that is determine whether the values given against each of the quadratic equation are the roots of the equation or not. So in that the first one we have x squared plus 4x minus 5 equal to 0, and we have to check whether 1 x is equal to 1 and x is equal to minus 1, whether they are the roots or not. So we'll start with 1. So the given equation is x squared plus 4x minus 5 equal to 0. So in this equation, in place of x, we'll substitute 1 in the left hand side of the equation. So in place of x, I'm substituting 1. So x squared, I get 1 squared plus 4 into x. So 4 into 1 minus 5 equal to, so 1 square is 1. 4 into 1 will give you 1 minus 5 equal to 0. So you have 1 plus 4 minus 5. So 4 minus 5, 4 minus 5 is 1 minus 1. So you have 1 minus 1 equal to 0. So you have left hand side also 0 and right hand side also 0. So LHS equal to RHS. So from here you can say that x is equal to 1 is a root of the given quadratic equation. Now we'll check for x is equal to minus 1. So we'll substitute x is equal to minus 1 in the left hand side of the same equation. So we get minus 1 square, so it was x square, so minus 1 square plus 4 into x, so 4 into minus 1 minus 5 is equal to, so minus 1 square is 1, 4 into minus 1 will be minus 1 and minus 5 as it is. So we have 1 minus 4 minus 5, which is equal to minus 8. So the left hand side is not equal to the right hand side. So left hand side we have minus 8 and right hand side we have 0. So we are getting non-zero. So from here I can say that x is equal to minus 1 is not the root of the given quadratic equation. So if you get 0, you can say after substituting the value of x, if you get 0, you can say that that value is the root of the given quadratic equation. And if you get non-zero, so in this case, you can see I'm getting minus 8, which is not equal to 0. So from here, you can say that it is not the root of the quadratic equation. So question number 5 of your practice set 2.1. So find k if x is equal to 3 is the root of the given equation. So in this quadratic equation, kx squared minus 10x plus 3 equal to 0. It is said that x is equal to 3 is a root. So what we'll do is we'll substitute x is equal to 3 in this equation and find the value of k. So x is equal to 3 is the root of the equation kx square minus 10x plus 3 equal to 0. So putting x is equal to 3 in this above equation, we get, so in place of x, I'm substituting 3. So k into 3 square minus 10 into 3 plus 3 equal to 0. So 3 square is 9. So you get here 9k minus 10 into 3 will be 30 plus 3 equal to 0. So just simplifying this, so minus 30 plus 3 will give you minus 27. So I have 9k minus 27 equal to 0. You take this minus 27 on the other side, it will be plus 27. So you have 9k equal to 27. Now if you take the 9 on the other side, it will get divided. So you have k is equal to 27 upon 9. So 27 divided by 9 is 3. So the value of k is 3. Practice at 2.1, question 6. One of the root of the equation 5m squared plus 2m plus k equal to 0 is minus 7 upon 5. We have to complete the following activity and find the value of k. So in the question itself, for the first block, if you see in the question itself, it is given minus 7 upon 5 is the root of the quadratic equation. So in the first block, I'll have minus 7 upon 5. Then we have to put m is equal to minus 7 upon 5 in the above given quadratic equation. So in place of m, I'll substitute minus 7 upon 5. So in the first block, we have 5 into m square. So 5 into minus 7 upon 5 the whole square plus 2 into minus 7 upon 5 plus k. Now if we try solving this, we'll have 5 into minus 7 square will be 49 and 5 square will be 25 plus 2 into, if you multiply these two, if you see 2 into minus 7, you will get minus 14 upon 5 plus k equal to 0. So here you will see 5 ones are 5 into 5, 25. So you have 49 upon 5, and this plus into minus will give you minus 14 upon 5, or you can just write it like this for now, minus 14 upon 5 plus k equal to 0. So in this below two blocks, you will see I'll have 49 upon 5 plus minus 14 upon 5 plus k equal to 0. Now to find this, the value in this block, what you do is you just simplify this. So I have 49 upon 5 plus into minus will be minus 14 upon 5 plus k equal to 0. Now if you see in this, the denominators are same, we'll just subtract the numerator. So I'll have 49 minus 14 upon 5 plus k equal to 0. So if you see 49 minus 14, we'll have 35 upon 5. So I'll have here 35 upon 5 plus k equal to 0. So you see here I'll have 5 7 the 35. So I'll have 7 plus k equal to 0. And now if you take this plus 7 on the other side, you'll have k is equal to minus 7. So if you see in that block, I'll have 7 plus k equal to 0. And if you take 7 on the other side, you'll have minus 7. So k is equal to minus 7.